Hi everyone. In this lesson we're going to talk about relations. So in logic, statements are either true or false, and in sets, elements are either members or they aren't. And in a relation, a pair either satisfy the relation or it doesn't. So in all of these things we've been looking at, there's sort of this binary relationship where it's either in or it's not, it's true or it's false, and so a relation is either satisfied or it isn't. The mathematical definition of a relation is very broad, so that we can use the definition to describe all sorts of relations. A relation between the sets A and B is just a subset of A cross B, and a relation on a set A is a subset of A squared. There's a special notation that we use for relations. If R is a subset of A cross B as a relation, then instead of writing AB as an R, we write ARB. And when we look at some examples below, you will see that you're probably familiar with this sort of notation already. And if AB is not an R, then we usually write ARB with a slash through the R. So let me show you an example. The example is a little bit unconventional, but I think it does a good job of getting the idea across. So A is going to be the set of words 1, 2, and 3. And B is going to be the two sentence fragments 1 plus 1 and 1 plus 2. So if I look at A cross B, I have the pairs 1, comma 1 plus 1. Right, that's my first element here. My second element is 1, comma 1 plus 2. The third one is 2, 1 plus 1, and so on. So we have 6 elements here. There's 3, 4, 5, and 6. So the last one is 3, 1 plus 2. So we're going to be defining R as a subset of this cross product, and we're going to take out all the true statements. Well, by true I mean that the first coordinate is equal to the sentence described in the second coordinate. So R is going to be 2, 1 plus 1, because 2 equals 1 plus 1, and 3, 1 plus 2, because 3 equals 1 plus 2. And those are the only two where the first coordinate is equal to the second coordinate. So since we've chosen the pairs where that they're equal, we're going to let R, instead of representing it R, we're going to represent it as equals. And equals itself is a relation. Two things are either equal or they're not. So instead of writing the pair AB as an R, we'll write A equals B, or A does not equal B. Since 2, 1 plus 1 is in R, we write 2 equals 1 plus 1. And similarly, 1, 1 plus 2 is not in R, so we write 1 does not equal 1 plus 2. So that's your first example of a relation. Let's take another example to show why that the definition is so broad, because we could pick any kind of subset. The subset may be meaningful or it may not be. So a relation is just sort of a way that you think about things. Another meaningful relation, though, would be less than. So if A is the set 1, 2, 3, 4, we can define a relation less than on A itself, which is a subset of A cross A. So we don't write out all of A cross A here. There would be 16 elements, but we will write out the set that represents less than on A. So 1 is less than 2, 1 is less than 3, 1 is less than 4, 2 is less than 3, 2 is less than 4, and 3 is less than 4. So we could say less than on A is equal to this set. And similarly to described above, we're going to use the notation with the R in the middle of the elements instead of the set notation. So instead of saying the pair 1, 3 is an element of less than, right? That's probably the first time you've ever seen that written, unless you've seen a similar lesson to this one. We're just going to write 1 is less than 3. So we put the relation in the middle. And we don't say that 4, 2 is not an element of less than. We say 4 is not less than 2, and we put a slash through the less than symbol. We could also write equals as a relation on A. And this looks pretty funny, but we'll say equals equals 1, 1, 2, 2, 3, 3, and 4, 4. Those are all the things that are equal inside of A. So once again, we don't say 1, 1 is an element of equals. We say 1 equals 1. And we don't say 1, 2 is not an element of equals. We just say 1 doesn't equal 2. and we write it 1 equals with a slash and a 2. So hopefully you can see that all sorts of relations could be written this way. And at the end I mentioned that, yes, we need some kind of context for thinking about the relationship, or it loses all meaning. So if A was the set 1, 2, 3, 4, and B was the set 1, 2, 3, 4, 5, so define the sets A and B here, one subset of A cross B is 2, 2, 2, 5. So 2, 2 and 2, 5 could be some kind of relation, but what sort of relationship is it? As stated, and without context, it doesn't really mean anything. So we're often only concerned with meaningful relationships. All right, I'll see you all in the next lesson.